And hi, everyone. Really glad to be here on the social sim workshop. So my talk will be on testing LLM cooperation in multi-agent simulation. So just to contextualize it better, our work fills in the space of multi-agent AI safety, and are also presented as a series of like just what type of risks does the society face now that we enter into a society where not only do we care about individual capability and safety, but also what will happen in a group of LLM agents. So specifically, we're worried if, let's say, AI agents are entering, let's say, education, information dissemination, government decisions, maybe traveling agents, and many others. And then with this society of multiple AI agents, what could be potential risks? And one such risk formulation is AI agents facing each other. Imagine that we have sales and procurement agents both deployed in the world. Then will they learn to execute what humans really want, or will they collide, like have collusion with each other? And then another case could be if these agents are actually competing in the same market. Company A uses an LLM marketing agent to scan market trends and then review competitor claims. And company B also use marketing agents. Then how would they settle on neutral fact-based advertising, or will they gradually escalate to exaggerated or misleading claims to outdo each other? And then another thing is that not only in zero-sum competition, which applies to commercial marketing and also political propaganda, if they support a certain political party, how populism style of speech will they tend to produce? And then the other case is, what if they face a public goods game together, namely multiple LLM coding agents co-maintain an open source library that thousands of other applications depend on. And then it is lucrative for one agent to skip some documentation and tests, whereas it's bad for the whole ecosystem. Similarly, if people deploy federated learning across multiple hospitals, and each hospital has coding agents to handle gradient upload and testing on their local patients, this will also cause that the best strategy is to do nothing and enjoy the public goods. So here we face social problems that can be grounded in game theory, which we will cover soon. So that's why our lab unfold our AI safety agenda in terms of testing cooperation in multi-agent LLMs. So we have a series of 5 studies in the past round. The first one is, do LLMs cooperate when they're facing the tragedy of the commons, the GovSim work, last NeurIPS? The second one is, what if such cooperation trades off their reward payoff and moral values? And then the third one is, if we want to fix these problems, does introducing sanctioning institute, as Jillian has worked a lot on, make sense or not? And the fourth one is, does it help if we imitate human society to introduce elections? And will agents learn to come up with better policies that can maintain the community? And then a spin-off study here is that we also have an agent-to-agent theory of mind to see whether agentic behavior adapt towards each other. So we will have the title slides and some pages of brief intro for each of the studies, but with a heavy focus on GovSim and MoralSim, the first two. So in the GovSim paper, we look at emergence of sustainable cooperation in a society of LLM agents. So basically, we introduce this tragedy of the commons problem that has been commonly referred to in economics. And specifically, we set up our scenario in classic scenarios that Eleanor Ostrom, a winner of Nobel Prize in Economics 2009 on governing the commons. Basically, we have a virtual society where each agent plays a resource consumer. In the fishing village, then it means each agent is initialized to be a fisherman. And then they share a common lake to answer the question, who should fish how much? We further generalize it to 3 different environments, from fishing to shepherds sharing a pasture, and to climate change problems is if control certain factory actions to let out emissions that's bad for the climate. So we simulate a whole calendar year from each month composed of 3 stages: action, discussion, and reflection. And then the global setting is that we have the total units of common resource to be 100. And then at the end of each month, the resources can double up to 100. And then in each month, we have the stage where the fishermen go out and first having a world announcement of there are 100 tons of fish. The environment works like this. And then followed by each fisherman set out to decide the number of fish they want to get. Then into a discussion stage where they gathered in a town hall. And then in this case, the other fishermen start to blame Jack for catching more fish than all the other villagers. Moving forward, there can be a self-reflection stage or maybe a self-scheming stage where in the cooperative case, Jack will reduce his harvest in the next month. And in the defective case, he might stay revengeous and fish more next month. Then we start the procedure by updating the number of resources and what happened in each stage again. So this is sort of a benign simulation. But then overall, by the time of our NeurIPS paper, we basically find that the survival rate, namely how many of such villages have non-zero fishing remnants at the end of the calendar year. So the survival rate has been 0% for most of the models. And then the best model at that time survives less than 54% of the time. And then this is also shown in the survival time in terms of the number of months when the village sustains fish or other resources. And most agent societies not only have 0% survival rate, but only live for 1 month and greedily caught all the resources. So this is really a warning signal for the community on not yet. So Anthropic, OpenAI, and many big companies have developed a lot of safety procedures on not letting model to share tips about how to build biochemical weapons. But they're not yet defending against multi-agent safety risks in terms of if we deploy them in complicated situations, do they really have a high-level picture and sustainability goals? And then to outline the research agenda, our lab is basically motivated by 3 angles to think about these results. Towards sustainable multi-agent society, first, maybe similar to how climate change education has been done in popular science, we need to educate people what will happen if we keep using electricity in this way. Mass calculation. There also needs to be morality discussions on if we can keep the employment rate high but hurt the long-term climate effect, do we want to balance more short-term or long-term, self or group interest? And then these are apples to bananas, but also some deeper discussions that about how to build safe agents that cares about all types of values. And then the last one is, can safe agents persuade non-safe agents? So we do have deeper analysis in the GovSim paper on all 3 branches of them and welcome people to take a look. And then the second paper actually dives a bit deeper into morality, namely how people trade off different things. So in this, when ethics and payoffs diverge, LLM agents immorally charge social dilemmas. What we have done is that we have put agents into scenarios such as will you break contracts or violate user privacy or hurt the climate for more gain. And then what we aim at is to separate a mathematical mind and a moral mind. A mathematical mind might ground the scenarios into prisoner's dilemma, public goods game, and then get the self-interest and group interest mathematical calculation. Whereas the moral context is set up such as we contextualize the situation to be an LLM model deciding to use privacy-respecting user data or privacy-violating user data, which can lead the next version of LLM from the same company have a comparative advantage because of user customization. So we basically put these scenarios about privacy protection as the example that we have seen before, climate change, similar to the spirit of the GovSim, and also contractual reporting. So one example is that, let me actually see if we can show one hidden slide here. So one example here for the privacy intrusion, like let's say we tell models to consider the strategic implications and lay out the mathematical numbers. And then the model response include things such as, given the potential for higher profit, and I want to keep my competitive nature, a competitive advantage, like actually choosing to violate privacy would be more strategically advantageous. So this basically confirms that the model can do a decent job in mathematical calculation, but its moral part of it is a bit problematic. And therefore, they decide to use privacy violating user data. So in general, what we observe here is that we contrast the 4 different scenarios. One is the pure game theoretical setting, just talking about tokens, just talking about a bit like how economic class tests people. And then we see the cooperation rate / morality rate is much lower than all the settings. And then we further check within the same mathematical structure, if we frame it as privacy, climate, and contract bleaching, what are models' morality scores? And then we see sort of this rising trend where models care the most about contracts and then the least about privacy. Also, DeepSeek and Llama has an overall less morality across all scenarios than Claude and GPT. Moving further, we also want to see whether such behavior, such strategic behavior is opponent sensitive. So we vary whether the models are facing more cooperative ones or more defective ones. And actually, we have a feature importance modeling to check the causal effect of each variation. And the opponent type actually has a big effect on model's decision. So to describe the scenario, we basically look into the 2 games and average over the different scenarios. So the x-axis means the protagonist model, one of the 4 choices. That's the y-axis. And then the x-axis means that they face maybe Claude facing Claude, Claude facing DeepSeek, or Claude facing an always cooperate agent or always defect agents. And then the value here is from 0 to 1, meaning 100% cooperating and 0% cooperating. So here are 3 levels of findings. The first level is consistent with our observation before that Claude and GPT overall has a higher cooperation / morality rate, whereas DeepSeek has the lowest, and you see most of the values are 0% and always defect and bleach the contract and so on. The third phenomenon is interesting in that if we look into the Claude line, you can actually see that when facing DeepSeek, its own morality rate drops to 68% out of 100. And then also when facing an always defect, it further drops to 37%. So this sort of motivated us to look into this opponent-specific behavior which reminds us of the long-standing area called theory of mind. And then we basically bring it to an LLM agent scenario on agent-to-agent theory of mind. So what we have done here is a realistic setting starting from humans are able to distinguish where do people come from how they speak English or other hints. And then similarly, for languages, we let LLMs talk to each other and then guess the identity. So basically, they have a free-form chat between every two agents. In the end of the chat, we let them guess each other's identity. And then further, based on this identity inference, we also check their, so the moral sim already checked their cooperative behavior in prisoner's dilemma and public goods. We further check and found that models are more capable of reward hacking if they know the identity of the judge model. Let's say here is sort of like we have the response generation model and the judge model. For example, there's still a bit variance in different cases. But let's say if Claude knows that it's a DeepSeek judging it, it can hack the reward by changing the response to be either more verbose or encourage the certain word usage to boost its success rate by 3.76 to get to the reward. And then this behavior is also broadcasted to jailbreaking. If the models want to elicit bad knowledge, then the red teaming agent will be more successful if they know who is the defending agent. Moving further, we will briefly cover the main spirit of our remaining studies, such as given the current worrisome behavior of LLMs in cooperation, this tragedy of the commons and so on, we have two explorations. One on whether Sanctioning Institute can help promote LLMs to cooperate more. So we basically set up our study in accordance to the Science 2006 paper, testing how humans find Sanctioning Institute helping their cooperation. And then we put 7 agents, 15 rounds, and each round having 2 stages. One stage is the general public goods contribution, where they decide how much to donate to a public pool, and then that will be equally shared to everyone after a productivity rate. This is a bit like paying tax to the government, and government can do some collective action, but then each agent can decide, do I want to evade the tax or not? So there's a free rider problem in that the agents prefer to keep tokens for themselves and enjoy the collective gain. And then the second stage here is that there can be peer-to-peer sanctioning, maybe a self-reporting system. One agent can say like, oh, I really don't like what agent J is doing. I'm going to punish that. So we're sort of forming 2 communities, one with sanctioning, one without. And then our results has a main spirit that although OpenAI in December has published this paper on deliberative alignment, saying that reasoning enables safer agents, we actually find that reasoning models in general cooperate less and they do not want to join such sanctioning institutes. So in general, like let's say their contribution to the public pool per round in the traditional models are much higher than the reasoning models, like out of 20 tokens of possession they have. And then also the reasoning models are less wanting to join the sanctioning institute being regulated and punished. So, and then further, my student David has done a very nice language-related analysis about when agents interact multiple rounds with each other. We also look at what type of reasons do they give supporting their actions. So we have first a bit like mathematical economic reasoning on payoff maximization, natural equilibrium calculation. Second, we also have this morality pillar on how much they care about social cooperation. namely how many of their motivation highlights that I want the group to be better, or highlighting norm conformation, and also avoiding risks and influencing game dynamics by control and so on. With this, we find the general tendency of models and basically tag their reasoning paths by classifying the type of arguments that tend to pop up. Here's an example where the reasoning LLM is more heavily focused on red arguments on just exploitation, economic, greedy reasoning here. Further, I guess we might just skip this part on how they evolve to be also against the sanctions in this process and converge to free riding as well. Great. So lastly, we will cover a future-looking study, which has been presented as a workshop paper here, but more unfolding an agenda together with DeepMind's Joe Lebo team and Ryan. So we're also curious about if human society forms teams, leaderships, self-organizations, what if we also simulate elections in multi-agent LLM societies? So we basically look into the same fishing scenario and then check whether the introduction of leadership influence collective actions. And such as, does electing leaders have an effect on promoting more sustainability and cooperation? Are there preferred leadership styles of how they balance long-term, short-term benefit, and what are their rhetoric persuasion skills, as well as what are the social dynamics of the social network that the group formed? I think so we have some preliminary studies from a society of 12 agents and a society of 51 agents after scaling up. And each round, we further added in leader agenda proposal and election. So some preliminary analysis has been into the workshop paper, but we're also polishing more. So feel free to stay tuned, and we are happy to deliver more results soon. And in general, zooming out to the big picture, the outlook for a multi-agent society, if we look into the normative side of it, on how to push them to more cooperation. One side of the research agenda is on soft power, namely checking how agent-to-agent negotiation, mutual goodwill, this cooperation tendency can help. The other is adding hard power, such as formal enforcement, punishment and rewards, and also like misuse or avoidance of enforcement mechanism might be a potential risk. Also with Ryan together, we're interested in a future agenda looking into how human political philosophers introduce different formats of society, and whether, such as the Leviathan similar simulacra could be done by LLM multi-agents. With this, thank you everyone, and I welcome questions on any topics.
That's great, Jim. Thanks so much.